Alrighty, let's see if we can't give you a few pointers on getting started with this. This is problem number 8 on assignment 3, dealing with step response analysis. So here's the circuit. At t equals 0, the switch closes. Prior to its closing, the 2 milliamp, let's see here, the 2 milliamp, let me set my color here. The 2 milliamp source is just going to be going through the 7 kilo ohm resistor. None of the energy will be going to the capacitor. Any energy that would have been stored on the capacitor would have drained through the 10 kilo ohm resistor. So the voltage across the capacitor at 0 minus is going to be 0 volts. And of course that is going to be then our initial voltage, V initial. We also know that after t equals 0, the voltage across that capacitor as a function of time is going to be equal to V final plus V initial minus V final, e to the minus t over tau. We already know what V initial is. We need to find out what V final is. We need to know what tau is. So to get V final, let's redraw this circuit. V final is going to be the voltage across that 10k ohm resistor. The capacitor is going to charge up until there's no more current flowing through the capacitor, and all the current will be going through the 3k and the 10k ohm resistor. Well, not all the current. We'll then have a current divider going, part of the current coming down here through the 7k, and part of it going over through there, through the 3k in series with the 10k. So let's redraw this circuit here. We've got 2 milliamps, 7 kilo ohms, 3 kilo ohms, 7k, 3k, and 10k, and we need to know what that voltage there is going to be. Well, the final, after the capacitor is completely charged, so the final voltage is going to be equal to the voltage across that 10k ohm resistor. Let's write it V sub 10k, which is going to equal the current flowing through there times 10k, which is equal to 10 kilo ohms times 10 to the third times whatever the current through that, let's call it I sub 10k, whatever that's going to be. Alrighty, well, we can get I sub 10k using a current divider. I sub 10k is going to equal the 2 milliamps, the 0.002, times the ratio of the 7,000 divided by the 7,000 plus the 3,000 and the 10,000 in series. So it'll be 7,000 plus the 13,000. And when we do that calculation, we get that it is 0.7 milliamps. So the V across the 10k is going to be 10,000 times I sub 10k, or plugging this in up here, we get then 10 times 10 to the third times 0.7 times 10 to the minus third. That equals 7 volts. Our final voltage is 7 volts. Now to get tau. Tau is the Thevenin equivalent resistance that we see looking back into there. We're going to deactivate the current source, which leaves us then with the 7k now being in series with the 3k, and the two of those in parallel with the 10k. So tau is equal to R equivalent times C, and we get then that that's equal to the equivalent resistance seen there is we've got 10k in parallel with the 7 plus 3, so 10k in parallel with 10k. That's going to be 10 kilo ohms in parallel with 10 kilo ohms times C. Well, that's 5 times 10 to the third times C, which is 2 times 10 to the minus sixth. So I'll let you take it from there.